Okay, so we have completed 26 problems, so we're going to move on to the 27th problem in the grind 75. This one is called O1 matrix. We're given 30 minutes, and so we're going to start the countdown now. Okay. All right. Given an M by N matrix, or binary matrix, MAT, return the distance of the nearest zero for each cell. Okay. Distance between two adjacent cells is 1. Okay, so conceptually that makes sense. So, of the nearest zero for each cell. So, basically we're going to output a matrix that is the same dimensions as MAT. So output matrix that is same dimensions as MAT. And it's going to have counts. Okay, so we have to be careful not to exceed boundaries. It's either a 0 or a 1. There is at least 1 0 in MAT. Okay, so will this be a sort of a recursive type of problem? Possibly. So I'm detecting O of n squared for complexity. Well, O of n times n, just because we have to hit the value in each row and column. Okay. But, okay, so say we're just looking at this example right here. Maybe we'll look at example 2. So starting at row 0, column 0, we're just going to look for the nearest 0. So first we're going to check if cell is equal to 0. So if cell is equal to 0, then return 0. We're going to move on. These are all zeros. Where the first one we're going to get to is here. So we're going to check in every direction that we can. So what is the most efficient way of doing so? We can, so there will always be at least 1 0, so we don't have to worry about searching the whole thing and there not being one. Say there's a 1 here and there's actually 1s everywhere except for this corner here. Then we'd have to traverse the entire array. So what would be the most efficient way? It would be to check what's most immediately close. So say we do 0 and we'd increment row, and then we would check what it would be like if we had incremented column, and then we increment both. Okay, and then we go back to having just incremented row, increment that once, maybe just what column was once, and then 1 column 2 row, 1 column 2 row, and then finally the diagonal. So that would be the best way to find the closest one, because we would check everything that's closest first. But how do we do that mathematically? We have to think. So increment the row ones, increment the column ones, then do both, and then reset 1 to 0, but this time because we'd already hit 1, check 2, and then do the same but flip, or It's also possible that we could be in the middle and we would just check all around. How can we write a general algorithm to do that? Well, so one thing we want to know is that we don't want to exceed mat.length, which is number of rows, or mat's some index.length. That's number of columns. So we have done a matrix problem before. How exactly we approached it, I'm seeming to not quite remember. How do we ensure that we're within bounds or indices? Don't go. So let's see. Go one, there's at least. So we have to grab indices. They have to be within bounds too. And we can have two counters, one for the row and one for column, so I and j. Okay. And we kind of want to, if we're looking at this example, example 1, the most efficient way would be to go in a spiral kind of method. So we would say +1 for the row, say +1 for the row, +1 for both, +1 for just for the column, +1 for both. So how do we do so? What's the proper way to change those values I and j? So we know we're going to check okay. Okay. So we know we're going to have I for, it's going to be row index, j is going to be equal to call index. We're going to make another, let's just call it cell. That's going to be just our iteration value. And no, that's wrong. No. Let's say maybe we'll have a while loop and we'll say while first we'll initialize int I is equal to 0. Similarly, int j will be equal to 0. And we're going to say while I is less than, what do we have? mat.length, and so to actually traverse through the matrix, I'm going to have actually R as row index, I'm going to have C as column index, and then I'm going to have I as, I guess, row, maybe we can call it padding, and J is column padding. And we'll kind of see what I mean in a little bit. Say we can initialize this out here. We're going to have a nested for loop to iterate over the entire matrix. So we're just going to say for int I, initialize that to 0 for as long as I is less than matrix.length. So this is going to refer to the rows. Increment I. Similarly, for integer j is equal to 0 for as long as j is less than or equal to the matrix at index I dot length. We're going to increment j. Okay, now we can traverse through the entire matrix. So again, first condition is if, what is it called? If the cell we are currently in, so if mat I j is equal to 0, okay. I also forgot that we are actually going to have to return a matrix of the same dimension, and we're going to have to insert at the appropriate value the distance. So we're just going to make an int, it's going to be called just result. It's going to be equal to new int with the same number of rows as the matrix and the same number of columns as the matrix. Okay, instantiate those pointers. We're going to use R and C for rows, and I and J for padding, basically searching outside of it. So if the value in our current cell is equal to 0, then we can add 0 to our result. And again, it should be row column will equal 0, which is what we want. Otherwise, we're going to have to do a certain kind of search, which maybe we want to put that in a separate function. So we can say int search on, well, so we have to say else, return, let's call it distance, int distance, or is equal to maybe some distance function. We're going to pass in the original matrix, mat, and we're going to pass in row and column. Okay, and then we're going to return, we're not going to return, we're going to set results in R and C equal to what distance is. Okay, end of that. And then in the end, we should just be able to return result. Okay, so that's that function done. We want to figure out what this function distance is going to do. So we can say private, which is going to return a value. It's going to be called distance. It's going to take in an array of arrays, a matrix. We'll just call it MAT. And it's going to take in indices. So it's going to take in an int called row and an int called column. Okay, and what it's going to calculate is the closest distance to a 0, because we know that the cell that we have found is not equal to 0. So how will we find that? So it seems like the fastest way, or I believe that, so the correct way, yeah, the correct way seems to be to have a sort of spiraling approach. So we know we'll eventually find some value. So the only thing we have to figure out is how that spiraling approach would look mathematically, as we said earlier in the video. But also we might be able to have these inside of the private function, actually. Or hold on. Is equal to. Yeah, we're gonna use a while loop. So what are we going to say? We could say, we could have an integer called found and set it equal to null. And while it's null, we're going to look for a value 0. And how will we get the distance? So say the value is here. Distance between two adjacent cells is 1. What is the distance between, is 0 considered an adjacent cell? Or I mean, sorry, is a diagonal considered an adjacent cell? That's a question that I would ask my interviewer. Is a diagonal considered an adjacent cell? So if we do consider it an adjacent cell, say maybe 1 is up here, and then we have the value we're looking for is here, or say it's here. So that would require us to go, yeah. So basically, the distance is the closest, or okay, we go 1, 2, and we go here. That's 1, 2. I'm going to treat the distance as the greatest value between the row or column that it takes us to get there. So if our starting value is here and you want to get to here, then I'm going to say that it takes us 1, 2. It's a distance of 2 away, essentially. Okay, so that's good. Let's say, so we increment 1, call the function, Well, let's see. Increment 1. So in a function call, we'll increment 1. In another function call, we'll have both of them incremented. In another function call, we'll have 1 incremented. So say we just do +1. We can check all the values. So if 1 is our value, and say we just want to look through all of these values, we can make I 1, and then, or we would actually make J 1, so then we would move over here, and then we would check all of the rows. And we could do the same if we went up here and check all of the columns. And then over here. But that seems sort of inefficient. What I would like to do is just check 1 each, and then step outside and check 1 each. So mathematically, again, how do we do that? If it seems to be pretty wasteful too. Then if we were to go to here and check 1 around, go to here, check 1 around, here, 1 around. That would be the easiest to do index-wise, but I'm sure there is some other better way to do it. I'm just going to do it that like brute force sort of way. I'm also going to have this public variable called found, which is going to be a boolean. And actually, initialize it to false. So we're going to say maybe, let's say while found, while not found, we're going to try just we can increment row by 1. and then check all the column values, increment column by 1, check all the row values, decrement. I just want to know the right way to do it. I mean, I don't want to do it in some half-baked kind of way. So if we know it's a spiral, that would be just, if we're thinking about the padding, it would be, say this is our 0, 0 index. We're going to do 0, 1, then 1, 1, 1, 0. This one's going to be 1, negative 1, and negative, or 1. I should really be writing this out, actually. I'm going to switch over to the drawing board really quick. So here we have, this is our 0 point. We have a grid, something like this. So this is 0, 0. This is row 0, column 1. This is row, this is above us. So this is row 1, column 1. This is 1, 0. This is 1, negative 1. The column is before that. Yeah. This is row 0, negative 1. This is row negative 1, negative 1. This is the row below us, and it's the column 0 still. This is also the row below us and the column to the right of us. So mathematically, what would be the best way to do this? So it's every combination of those. So it would be, we could say it would be negative 1 through 1. And then if it was none of those values, this is the same for row and column, we would do negative 2 through 2. And it doesn't exactly matter which order we do it in, just matters that we get through all of them. So maybe I would have one for loop. The only thing is it would check itself. And then as soon as you move to 2 and 2, we would also be iterating over these values here, negative 1 through 1. But we don't want to do that. You want to skip over those values. So negative 1, 0, 1. But in the negative 2, 2 case, that's a little bit more challenging. We essentially always need to have a 2. either in the row value or in the column value. But in the other value, we can have any number between -2 and 2. So yeah, that seems to be it actually. That's the timer. Okay. I think we did a lot of good thinking about, you know, how we should go about traversing this matrix. I'm sure the solution will put it in a much more succinct way. Hopefully that will stick with me when I actually encounter another matrix problem.